Hello everyone, welcome to this video on Boolean Algebra. This is actually my first video on this series, and please, if you're not subscribed to my channel, please subscribe and hit the bell, okay? So welcome, and let's go straight to Boolean Algebra. So what is Boolean Algebra? Boolean Algebra is just a kind of algebra that was named after this scientist right here. The name is George Boole, okay? So you can just go and read about him later on. So Boolean algebra will deal with Boolean variables, all right? So what kind of variables are Boolean variables really? These variables can only take two kinds of values, all right? And the two kinds of values are zeros and ones, just as I've written here, okay? So Boolean algebra, you'll be dealing with zeros and ones, all right? And then there are some logical operations that you'll be performing using the Boolean variables. Okay, so now, what are the basic operations? They're just three, okay? The basic operations of Boolean algebra are just three. There's the logical addition, okay? Also called the OR operation. We have logical multiplication, also called the AND operation. And then we have logical complementation, okay, this one. Logical complementation, also called the NOT operation. Okay, so any other operations that you'll be seeing in Boolean algebra, for those of you who know things like, XOR and maybe XNOR and okay, so these are just derived kind of operations. We'll be getting them once you understand the basic ones, because you can see there's an OR here, there's an OR here, okay? Some operations like the NAND. So we have NAND operation, which of course you can see the word AND there, and AND is a basic logical multiplication, all right? So now all you need to worry about at the moment is to understand these three basic operations, and you will be good to go, okay? So the OR operation is actually symbolized by a plus, okay? So if you see a plus sign, that will mean OR operation is being done, okay? It can be, let's say, variable A or variable B, can be written like that. You can see variable A and with and variable B. That's logical multiplication of those two, okay? Now, the special thing about the NOT operation is that it can only take one kind of variable, all right? So you can just have NOT A, okay? So NOT A, that is a NOT A, or you can have the whole of A or B. Let's say this guy down here. The result of A or B, we are getting the complement of that. So that is not A or B. It's how we read it. But don't worry, because we'll be doing this step by step, okay? Until everything is clear enough. All right. So now, let me just show you how the logical addition works. So we'll have, this is an example of a logical OR gate, okay? So the OR gate looks this way. The points to note are that it's curvy, okay? It's curvy that way. And also where these variables are coming in, it curves inside like that, all right? So this is an example of an OR gate. In short, this gate, what it does is, let me show you, it's taking A, adding it with B, okay? To give you the output, which is Y, all right? Let's look at the AND gate and how it works. So the AND gate looks like this. Here it is. So this is our AND gate, okay? AND gate, it's different from the OR gate because it's flat where your variables are coming in, all right? It's also a straight line on the sides and only curves towards the end, all right? So that's the difference between an OR gate and an AND gate. If you check well, the OR gate was curvy all through, okay? Curvy from the back, curvy sideways, and then it ends in a pointy manner, all right? So now let's get back to the AND gate. So this gate, what it does, it takes A, it multiplies with B, all right? Remember we said and operation is the logical multiplication. So you just take A, you multiply with B to get your output Y. All right. If you're doing the complementation, the logical complementation, this is the kind of gate that you'll be going through. So this is called a NOT gate, all right? Logical complementation is a NOT operation. So what it will do, if your A is 1, it will take something that is not A, okay? So what it's doing here is actually doing NOT A. And NOT A will be a 0, because we've just said that Boolean algebra work with only two kinds of values, zeros and ones. So if you don't want 1, like in this case, we're saying not 1, then it will give us 0, okay? If you have 0 here, and you're taking it through this gate to be a not 0, okay, the Q value will be 1, all right? That's basically how a NOT gate works, okay? But don't worry, we are doing more on logic gates in the second video, so don't forget to tune in. Thank you very much.
Audio Jungle.